All right, moving on to the reactions of the alkenes here. The first reaction that we're going to look at is the combustion reaction, where it burns with oxygen to produce carbon dioxide and water. This is ethene. And to begin with, all of the numbers out the front of these molecules are ones. So I can do that in light blue. I can put ones out the front of these because that's what they are at the moment. Clearly this isn't balanced, and we're going to change those numbers to make sure that we've got the same number of each type of atom on each side of the arrow here. Now we can only add more of this, or more of this, more of this, or more of this. We can't take anything away, and we can't add parts of molecules. All right, we've got to have whole numbers here, and yeah. So that's pretty much it. So let's start off on this side here. I covered this in the previous one of the previous videos. So if you're unsure about the process, go have a look at that first, the one with the alkanes. Now this one here, C2H4. Okay, so let's go from left to right. I've got 2 carbons here and 1 carbon here. So if I make that a 2, I now have 2 times 1 equals 2 carbons on this side. So far we're good. 2 carbons here, 2 carbons here. Look at the hydrogens. I've got 4 hydrogens here. I've got 2 here. So if I double the number of waters, I've now got 2 times 2 is 4 hydrogens. 4 hydrogens here. Fine. So far so good. We can keep that as a 1. That's all right. It's looking good. Now we do the oxygens. This is always the tricky part with these combustion reactions. I've got 2 on this side, and that 2 is in a single molecule. So I can't just add 1 oxygen. I have to add lots of 2 over here. Now on this side, I've got 2 times 2 is 4, and 2 times 1 is 2, which gives me a total of 6 on this side. I need to turn this side into a 6, so I times that by 3, and that's how I get a 3 there. So that one's done, no worries. Let's look at a slightly more difficult one, propene. Okay, so this time I'm going to assume that you can see the ones in front of the molecules there. I'm just going to leave them out. Again, we go from left to right. This is carbon first, 3 carbons here, 1 over here. So I have to multiply that by 3. We're done with the carbons, nice and easy. 6 hydrogens here, 2 hydrogens here, and 3 times 2 is 6. Then we get to the oxygens once again. We've got 2 on this side as a single molecule there. On this side, I've got 3 times 2 equals 6. And I've got 3 times 1, which is 3, giving me a total of 9 on this side. Now I have to find the multiplier that turns 2 into 9, and 2 times 4.5. Oops, that's a very badly drawn 4. 4.5 there gives me the 9. So I can put a 4.5 there. But as described previously, we don't want fractions in our balanced equations. So what we're going to do is times all of that by 2, and that's going to give us 2C3H6 with the gas there, plus 9O2 gas goes to 6CO2 gas plus 6H2O. Also gas. Now when you're doing these, demonstrating the steps required to get this final balanced reaction here, you are going to have to show this first, and then you are going to have to do this. If for some reason you're just able to miraculously produce this out of thin air, you're only getting the last mark for the question, which is the answer mark. Okay, so show the steps in the working out. Now you need to go through the rest of these, butene through to decene, and do the balancing of the equations. If you can already do it, it's not going to take you very long, and if you're not good at it now, then you're going to get better at it pretty quickly. You have to be able to do these. Now what you'll see as you go through balancing each of these reactions in sequence is that when the carbon, for alkenes, when the carbon has an even number, you don't get the fraction here. When it has an odd number, you do get the fraction here. If you were paying attention to what you were doing with the balancing of the equations with the alkanes, you would have noticed that that was the opposite. When this was an odd number, you had no fraction here, and when it was an even number, you got a fraction here. So there's some sort of relationship going on there, and it's got to do with the number of hydrogens in the molecule. You can also do these reactions with the alkynes, and you can see if you can figure out beforehand what the pattern will be with those. I'm not going to do the alkyne reactions because they're exactly the same as the alkenes and the alkanes. So go through those. There you go, job for you.